Hello, Algebra 2. We're going to be taking a look at our 8.6a guided practice problems where we are going to be graphing equations of conic sections not centered at the origin. So up to this point we've been assuming that our circles and our ellipses and our hyperbolas were all centered at the origin, a very convenient place to have a center, and that our parabolas vertices were always on the origin as well. Well, it is possible to write equations of each of these conic sections, our circles, parabolas, ellipses, and hyperbolas, that don't happen to be centered at the origin or don't have a vertex at the origin, and that's what we're going to take a look at today. So we're going to start with the general form of the equations, and they're going to look similar to what we're already familiar with, except we're going to all of a sudden see this h and k show up in these equations that we're not accustomed to seeing. If only this h and this k were 0, we would know our circle equation is x squared plus y squared equals r squared, and we're already familiar with that. Well, we can have a center of our circle not at the origin, and that's what these h and k numbers are going to tell us, where that center is when we're not centered at the origin, and we're still going to be able to find the radius from our r squared. Our parabolas, well, we know when we are working with our parabola equations that if we start with x squared, they'll open up or down. And if we start with y squared, they'll open left or right. And so we can see again, we've got this extra h and k showing up here. And that would be the case if the origin were the vertex of the parabolas. The h and k would just be 0 and it would disappear. But if our vertex of our parabola is not at the origin, the h and k tells us exactly where the vertex would be. Notice that the h always pairs with the x and the k always pairs with the y, no matter how we're writing the equation. And that will be consistent through our parabolas, ellipses, and hyperbolas. X and h always pair together, y and k always pair together. All right, for our ellipses, we remember x squared over a squared plus y squared over b squared equals 1 if we have a horizontal major axis. Well, that would be the case here as long as h and k were 0, and when we did have our centers at the origin for our ellipses, that was the case. But we can center our ellipses other than the origin, and the h and k numbers are going to tell us where that center is. If we have a vertical major axis for our ellipse, then we would have our b squared underneath our x minus h squared and our a squared underneath our y minus k squared. All right, finally for our hyperbolas, our general forms of our equations. If we have a horizontal transverse axis, and that would mean that the branches of the hyperbola open left or right, then we would have the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. And so remember that the transverse axis is determined by what comes first here, and we see the kind of the remnants of our x squared here, and if h and k were 0, we would recognize that x squared over a squared as our first fraction. The h and k will simply tell us where the center of the hyperbola is if it's not at the origin. Similarly, if we have a vertical transverse axis, if the branches of our hyperbola open up or down, we would have the y squared term comes first, and in the case where we're not centered at the origin, the y will pair with the k, and the x will pair with the h, and we would be able to easily write the equation of a hyperbola not centered at the origin. All right, let's see what this actually looks like, because these general equations need to be practiced before they make any sense. So we're going to do one of each of these different types. We're going to graph first the equation of a circle, and we're going to include in our graph important characteristics on that circle. So I'm going to step you through what those important characteristics should be as you're completing these problems in your homework on your own. So here we recognize this equation as the circle equation not centered at the origin. So we see the h and the k as numbers 1 and -3. To find out where that center is of that circle, we're going to pull these numbers out, but we're going to write down their opposite. The opposite of +1 is -1. The opposite of -3 is +3, and there's the center of our circle. So we'll start by putting that center down on our graph, -1, 3. Then the next step is we're going to find the radius. Well, we know the radius squared is 4. So the square root of 4 is 2, so the radius is 2. What that means is we start at the center, and we plot a point 2 spaces to the right, 2 spaces up, 2 spaces to the left, and 2 spaces down, and we draw a circle through those 4 points. And we have drawn the circle correctly then with a center at -1, 3 and a radius of 2. We'll go ahead and make sure that we identify those 4 points and the center with their correct ordered pairs, and we have completed then graphing the important characteristics of the circle that is not centered at the origin here. All right, our guided practice 2 will have us practice with graphing a parabola. This one is going to happen to open up or down because we see the x squared term first, and so we're going to use this equation. Of course, there are two possible parabola equations that we could reference. The other one would be y minus k squared equals 4p times x minus h. So depending on what we are observing here, we would pull off the correct equation. And again, we're going to use that h and k, those numbers, and in this case that will represent the vertex of this parabola that will not be centered at the origin. So we're going to pull out the opposite of those numbers. The h and k number is always the opposite of what you see in those parentheses. So the vertex of this parabola is at 2, -3, so there it is on my graph. And then I'm going to find the focus in this case. That's the only other detail I'm going to provide in my graph. So 4p is 8, and how do we know? 4p is our 8 here. And so we're going to solve for p, and p is 2, and since p is positive, we know the parabola opens up, and it will open up on the vertex 2, -3, that we figured out here. And the focus, of course, will be inside. So because the p is 2 and because the focus is inside, we know the x-coordinate is going to have to be 2. It couldn't be 0, 2. It couldn't be that way because that would put the focus over here, which makes no sense. It has to align with our vertex here. Okay, so we have drawn our parabola. We don't know exactly how wide or how skinny it is. We're just simply going to open a parabola up on the vertex and place the focus inside, and that's as much detail as we'll provide for graphing our parabolas that don't happen to have a vertex centered at the origin. All right, the next one, guided practice 3. We're going to recognize this as a hyperbola equation. We see that minus sign. So this is the equation we're going to pull off and use. So that means that we will have a horizontal transverse axis because the x squared part comes first. Let's go and get our center pulled out of the equation. The opposite of 3 is -3. The opposite of -4 is 4. So there's the center, which I put in my graph here. And then I'm going to pull out my a squared and my b squared from the denominators here. My a squared comes first when we have a horizontal transverse axis. It'll be underneath the x squared term. So a squared is 1, a is 1. We get that from here. And b squared is 4, b is 2, taking the square root. And now we're ready to plot points based on these a and b numbers. We're going to plot points 1 to the left, from our a is 1, and right of the center, and 2, that comes from our b, 2 up and down from the center of -3, 4. So we go to the left one and to the right one, up 2 and down 2 from that center point, and then we're able to draw that rectangle and the asymptotes through that rectangle, and we're able at that point to know where the branches of our hyperbola are. Here are the vertices, and then we're going to use those asymptotes to guide the branches. We're going to open those branches so that they approach those asymptotes but actually never touch it or cross over it. Now, we could actually figure out where the focus points are for this graph. However, we have enough complexity going on here when we are graphing our hyperbolas that don't center at the origin, so we'll skip including the focus points when we are graphing when the center is not at the origin. Okay, last guided practice problem where we're graphing an ellipse. We're going to recognize this as an ellipse equation, and here is the equation we're pulling off from our key concept. We notice that the 16 is greater than the 9, so we have a major horizontal axis. Our a squared is under the x squared term, not underneath the y squared term. So remember, for our ellipses, whichever is the bigger number here, that's going to determine your major axis, and in this case that would mean it's horizontal because it's underneath the x squared. Okay, so let's get our center of our ellipse. The opposite of -2 is 2, the opposite of -1 is 1, so there's our center, and I've already put it on my graph here. And then we're going to find out our a and our b, so we're going to pull the 16 off for our a squared and the 9 off for our b squared. That means a is 4, b is 3. So starting at our center point, I know that I have to go 4 to the right, because my a tells me that I have to go 4 to the right and 4 to the left of the center. That's going to be my major horizontal axis. And then I'm going to use the smaller number to go up and down, because that's going to be my minor axis for this ellipse. So up 3, down 3, and I'm going to go ahead and label all those points that I have determined with the correct ordered pairs. And this does look a lot like a circle, but that's only because the 4 and 3 are so close together. The further apart these numbers are, the more it looks ellipse-like and less circle-like. So here I've noted my vertices, my co-vertices, because I see them right here on my ellipse that's not centered to the origin. And again, just like our hyperbolas, we're going to skip figuring out where the focus points are. They're, of course, someplace inside of our ellipse here on this major axis, but we're going to skip the focus points just because we have enough complexity going on when we're graphing these conic sections that do not center at the origin. All right, so use these to guide you through the problems in your homework. We have one example of each of the different conic sections, our parabolas, our ellipses, our hyperbolas, and our circles. All right, we'll see you next time.